Calculator! Calculator problem. Also see decimals. Must be calculator problem. What is the area of the region in the first quadrant bound by the left graph? Ooh, this is a left graph. And the right graph. Ooh, that's the right graph. Okay, left and right. Okay, but something really weird is happening. I might ignore the left and right thing. This is a function of y. It's not a function of x. And that is also a function of y, not a function of x. What? Now, we can only plug in functions into our graphing calculator, and we don't have a y variable. That's okay. I'm going to ignore it. I'm just going to say y equals x to the fourth plus y squared. Oops, not y squared, x squared. And y equals 5y. It's not a big deal. I'm just switching the x and the y, and here's the thing. If we're only in the first quadrant anyways, the function must be happening over here or over here, doesn't matter. And if it is over here, then if I switch the x and the y, I'll just end up over here. So we're going to end up in the same quadrant. So I'm not worried about switching the x and the y. So let's plug in our functions. We have x to the fourth raised to the fourth plus x raised to the second. And then our other function in y sub 2 is going to be 5x. Oh, I wrote y. What a goober. Okay, so let's take a look at what our graph looks like really quick. I hit the graph and booyah. Yep, see, just as I suspected, we have this curve, we have a line like this, and if you reflect that over the y equals x axis, like if we switch the x's and the y's, it's just going to end up over here. We're going to have a line like this and then another line like this. It's going to do the same thing. Okay, so we can just pretend that we have a y-axis here, and this is the x-axis. So whatever our calculator says is the x is actually the y, and the y the x, whatever. So if we want to find the area between those two curves, we have to take the top curve and minus the bottom curve. Which one's our top curve? Ding, 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 that guy's the winner. So it's going to be the integral of 5y minus, I'm going to use the actual function right there, 5y minus the other dude, which is y to the fourth plus y squared dy, and we're going to go from 0 to, what is this y value right here? Let's find that by using the intersect function on our graphing calculator. Now looking at our graph, I'm going to hit second and then trace. That's actually a calc button once you hit second. And then I'm going to select intersect. On my calculator, it's a 5. Now my calculator is weird. It's asking for the left bound and the right bound. Your calculator, most likely, if it's a Texas Instrument, will say, what is the first curve, what is the second curve? So you just have to select them. It's pretty much you're pressing enter twice if those are the only two curves on your graph. And then you have to drag the cursor over to close to the point of intersection that you want, and then press enter. If you don't drag that cursor over towards the point of intersection that you want, the graphing calculator will choose whatever one it wants to choose. So here's my left bound. Wait, where's my... You know what? I think I'm just gonna, there they are. There's my left bound right there. And then I have to pick my right bound on the other side of it. And then boom, it found the point of intersection at, see, it says P1, 151598. So I'm gonna say 1516. And I'm gonna plug that into my graphing calculator. So let's go. Ooh, also I need to know which one's y sub 1, y sub 2. This one is y sub 2, and this one is y sub 1. So I'm going to go y sub 2 minus y sub 1. Second quit to my home window. Now I'm going to hit math 9, F-N-I-N-T, to get inside an integral here. And I'm going to hold 0 and then 1.516. Yep, everything's right so far. Now, since I already have my functions inside my graphing calculator, I'm going to go I pressed vars. It's right underneath the arrows. And I'm going to go y vars and then function. And I'm going to select y sub 2. Then minus the bottom function. So vars, y vars, and then function. I'm going to select y sub 1. And then get out of there and hit enter. Boom. There's my answer. It is 2.983. Shoot, there it is.